welcome back. This is Mrs. Rubright with Algebra 1 Honors, and today's lesson is 9-4, Linear, Quadratic, and Exponential Models. Alright guys, so equating exponents when solving equations. Two powers with the same positive base other than 1 are equal if and only if the exponents are equal. So in algebra, if b is greater than 0 and b is not equal to 1, then b to the x equals b to the y, if and only if x equals y. So for example, if 2 to the x equals 2 to the 9, then x equals 9. If x equals 9, then 2 to the x equals 2 to the 9. Okay? So, let's solve these equations. So, if we have, solve each equation, 5 halves times 2 to the x equals 80. So the first thing that we're going to do is we're going to multiply by 2/5 on both sides to get rid of the 5 halves. So we're left with 2 to the x equals 2/5 times 80 is 32. Well, what is 32? 32 is the same thing as 2 to the what? 2 times 2 times 2 times 2. Well, that's going to be 4 times 4, which is 16. So times one more. 16 times 2 is 32. So it's 2 to the 1, 2, 3, 4, 5. So x equals 5. Right? What else can I do? At this point here, I could have also done logarithms, right? I could have just added a log to both sides. And then pulled the exponent out front. X log 2 equals log 32. Divide by log 2. And I would have gotten the same answer. So, 32 log divided by 2 log equals, and I got x equals 5. So you can use logarithm. You can use the Algebra 2 stuff. Or you could use this. We want you for this lesson to practice doing the exponents. But if you get stuck, you can always go back to the logarithms that I already taught you guys, okay? So there are two ways of doing this. They want you to practice the exponents. This is the Algebra 1 skill. This is the Algebra 2 skill that you're not supposed to know, but your teacher taught you it. And this is your get out of jail free card. If you get stuck, you can always use logs. All right, so to get rid of that 4, the opposite of 4 is 1/4. So I'm going to multiply by 1/4 on both sides to get rid of that 4. Leaving me with 5/3 to the x equals 125 over 27. Okay, so now 5/3 to the x equals 5/3 to the what? 5 to the what is 125? 5 times 5 is 25 times 5 is 125, so to the third. 3 times 3 is 9 times 3 is 27. So that means that x equals 3. How can you check a solution? So, to check the solution, can't we just go 4 times 5/3 to the third equals 500 over 27. So let's check this with our calculator. So I'm going to take my calculator. 5 over 3 to the third times 4, and I got 18.5185. 500 divided by 27 is 18.5185. Those are equal, so we know that we didn't mess anything up and that it works, right? So 5/3 to the third times 4 gives you this. 500 divided by 27 gives you that. It's an equivalent equation, so we know that we're good. So my answer for here is plug back in. And make sure you have an equivalent equation. All right, how can you work backwards to write 125 over 27 as a power of 5/3? Well, isn't that 5 to the third? 125 is 5 to the third, and 27 is 3 to the third. So that means that 5/3 to the third is equal to 125 over 27, right? Is it possible to solve the equation 2 to the x equals 96 using the method in the example? Why or why not? 2 to the what equals 96? Well, let's see. Let's try. So 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. 16 times 2 is 32. Times 2 is 64. Times 2 is 128. Too big, right? So it's not gonna work with 2 to the something. So no. And why not? Because 96 is not a whole power of 2. Right? Solve it with logs and see what it would have been. So with logs, it would have been log 2 to the x equals log 96. So you'd have x times log 2, because the exponent comes out front, equals log 96. Divide by log 2, and you get x equals 96 log divided by 2 log equals 6.5849 da 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 da. Right? It's not going to be a whole number exponent. All right. Some equations can't be solved using the method in example 1 because it isn't possible to write both sides of the equation as a whole number power of the same base. Instead, you can consider the expressions on either side of the equation as rules for two different functions. You can then solve the original equation in one variable by graphing the two functions. The solution is the input value of the point where the two graphs intersect. So they're saying you could graph y equals 2 to the x and graph y equals 96 and see where those two graphs intersect. Does that make sense? Or logarithms. Just fast forward a couple years in math and it's faster, right? Yeah, yes. Write an equation and solve by graphing. A town has 78,918 residents. The population is increasing by a rate of 6% per year. The town council is offering a prize for the best prediction of how long it'll take the population to reach 100,000. Make a prediction. Write the exponential model to represent the situation. Let y represent the population and x represent time in years. Okay, so we have y equals 78,918 times 1 plus what? We want 6% per year, 106%. 1.06, right? 106%, as a decimal, move 2 places away from the percent sign and drop the percent sign, 1.06. Oh, wait, what did I just do? It's 1.06 altogether. They gave me the 1 separately. Sorry, 0.06. Now when I add these together, I get the 1.06. I didn't see that they already had the 1. Sorry about that. Right? They had the 1 for the whole plus 0.6. So 1.06 is, I normally just write it as, 1.06 and skip the step of having them separate. All right, write an equation in one variable to represent the time x when the population reaches 100,000. So 100,000 equals, okay, so f of x equals, write the functions for the equations on either side. So they're doing one for 100,000 and the other one for 78,918 times 1.06 to the x. What type of function is f of x? What type of function is g of x? So f of x is what? It's linear. It's going to be horizontal, right? Y equals something. It's going to be horizontal and linear. Okay, so f of x is a constant function or a linear function. G of x is an exponential growth function. We have a linear function and an exponential growth function. Graph the functions on a graphing calculator. Let y to the first equal f of x and y2 equal g of x. Sketch the graphs and include the missing values. Okay, so we're not going to use a graphing calculator, so I'm just going to show you what this graph should look like. So this right here is your, let's see, hold on. What were your 2 points? So you had f of x equals that, and g of x equals what's that? Yeah. So the way that they show the graph right here, they have this one, and they have this is your f of x equals your constant, right? And then the exponential one's here. And then their point of intersection, which you can trace on the graphing calculator, tells you that it's 4.063245, which you would get on the graphing calculator. Okay? Make a prediction as to the number of years until the population reaches 100,000. So the population will reach 100,000 in just over 4 years if it continues on the same pattern, right? Suppose the contest is announced on January 1st and the town has 78,916 residents on that date. Explain how to predict the date on which the population will be 100,000. So just also going back to this real quick, how you could do this problem with logarithms. So since you guys are not using a scientific calculator, you could do this problem just like this. So you would have 100,000 divided by 78,918 equals 1.06 to the x. So you'd have log of 100,000 over 78918 equals log 1.06. The x comes out front. So divided by log 1.06. And you would have your answer. So now at my calculator, 100,000 divided by 78918 equals log divided by 1.06 log equals x equals 4.0632. So even though you guys don't have graphing calculators, you can still do it because you now know how to use a log. Right? You can use logarithms to get the same answer without having a $100 calculator. Okay? Because this calculator will do logarithms. So it does everything that you need it to do. All right, so suppose the contest is announced January 1st and the town has 78,918 residents on that date. Explain how to predict the date on which the population will be 100,000. So we said that it would be just over 4 years. So just over 4 years from January 1st. So the number of years, 4.06, represents 4 years plus 0.063245 of a year. There's 365 days in a year, so we can actually calculate the precise time. So if we're going for, what is 0.063245, right? Of means multiply, of 365 days. So 0.063245 times 365. So it's going to be 23.08 days. So if we're going from January 1st, it's going to be 23 days later. What's that going to put us at? January 24th, 4 years later. Approximately, right? Explain why the x-coordinate of the point where the graph y1 equals f of x and y2 equals g of x intersect is the solution of the equation in part B. Because if you set both sides of the equation, if you graph both sides of the equation separately, where they intersect will always be your solution, right? We just kind of, that's a different method that we can use. And why are we able to use that method? Do you guys remember when we had two things like solve for y, and then we could substitute them into for each other, kind of like the transitive property, we sub them in for each other? So it's the same concept. So that's why you can do, it's like separating them back into two separate equations. Does that make sense? And that's the theory, or the method behind it. In the previous example, you knew the growth rate and were able to write an exponential model for the situation. However, in many real-world situations, you may only have data points with which to create a model. For situations that can be modeled exponentially, you can use exponential regression feature on your graphing calculator to create a model for the data. This data shows the number of internet hosts from 2001 to 2007. Enter the data on the table into the graphing calculator. We're not going to do that because you guys don't use graphing calculators, so we're just going to cross this part out. All right. Graphing residuals. We're not going to do this either. Okay. So, practice. Solve each equation without graphing. So the first thing we're going to do is we're going to divide by 5 on both sides. And we get 3 to the x equals, what's 405 divided by 5? 5 goes into 120 times, so that's 20, 40, 60, 81 times, right? Well, what is 81? It's 3 to the what? 1, 2, 3, 4. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 3 to the 4th. So x equals 4. Yes. Yes. Multiply by 5 on both sides. 5 to the x equals 25. Well, what is 25? 5 what? What is 25? 5 squared. So x equals 2. Try number 3 with your table partner. All right, so you guys first divide by 10 on both sides. 4 to the x equals 64. 4 to the what is 64? 4, 4, 4, 4. Okay, so 4 times 4 is 16. 16 times 4 is 64. So just 3 of them, right? So 4 to the x equals 4 to the third, so x equals 3. Try number 4. times 1/7 on both sides, you get 1/2 to the x equals 1/8. 1/8 is 1/2 to the third, right? 1 to the third is 1, and 2 to the third is 8. So it's going to be to the third. So x equals 3. Try number 5. Oh, that's 3 to the 4th. All right, well, isn't 16 over 81 2 to the 4th over 3 to the 4th, or 2/3 to the 4th? Right? You guys get that? And try number 6. You guys get x squared? X equals 2? X equals 2? All right, guys, so 6 to the x equals 150. So these, it says to solve by graphing, which means that these are not going to be nice and work. So instead of graphing, because that's just really annoying, log them. X log 6 equals log 150. Log divided by 6 log equals, I got 75.5. I did not get that. I just did it again in my calculator, and I so did not get 75.5 the second time I put it in my calculator. Did you guys get something else? What did you get? 2.796? 2.8? Sorry, I must have messed up in my calculator the first time. $1.9? Oh, nearest hundredth. 1.86. Sorry, guys. It says hundredth, not 10. 1.86. Doesn't work either. Switch my red. Alright, so then x log 2.5 equals log 40. 40 log divided by 2.5 log equals 4.03. Good? Last year, a debate club sold 972 fundraiser tickets on their most successful day. This year, the 4 club officers plan to match that number on a single day as follows. To start off, on day 0, each of the 4 officers will sell 3 tickets each and ask each buyer to sell 3 more tickets the next day. Each time a ticket is sold, the buyer of the ticket will be asked to sell 3 more tickets the next day. If the plan works, on what day will the number of tickets sold be 972? Write an equation in one variable to model the situation. So talk with your table partner and come up with what you think would work. What do we want it to equal? 972. What is our first amount, our initial amount? There's 4 officers selling 3 each. There's 12 initial tickets, right? And then they're going by 3s, right? Our common ratio is 3 to the x. Right? Because each of the people we sell it to, they have to sell 3. So 3 to the x times the 12 initial, and it's going to equal the 972. So what are we going to get? Well, 972 divided by 12, 81 equals 3 to the what? 3 to the what is 81? 3, that's 9 times 9, right? So 3 to the 4th equals 3 to the x, so 4 days. There are 175 deer in a state park. The population increases at a rate of 12% per year. At this rate, when will the population reach 300? So 300 equals, how many did they start with? What's it going up by? 1.12, 112%. Divide by 175 on both sides. 300 divided by 175. Personally, I would use logarithms. Right? So we have 300 divided by 175 equals log divided by 1.12 log equals, I got that x equals 4.756, right? 4.756 years. Suppose there are 200 deer in another state park and the deer population is increasing at a rate of 10% per year. When will it be will it reach 300 sooner? Okay, so 300 equals the initial 1.10 to the x. So 300 over 200 equals 1.10 to the x. Add logs. Bring the x out front. So you're going to have log 300 divided by 200, right? All over log 1.1. Okay, so 300 divided by 200 equals log divided by 1.1 log 4.25 years. So yeah, they'll be sooner. Yes. Right? It's going to be sooner. It's going to be in 4.25 years versus 4.75 or 76 years, right? A city has 642,000 residents on July 1st of 2011. The population is decreasing at a rate of 2% each year. At that rate, in what month and year will the population reach 500,000? Explain how you found your answer. 500,000. You started with 642,000 times, if it's going down 2% each year, it's really only 98% of the year before, right? 1 minus 0.02 is 0.98 to the x. So you're going to have 500,000 divided by 642,000. Right? You're going to divide that out on both sides, and then you're going to make logarithms, so it'll be a log. You're going to divide by log 0.98. So your answer is going to be whatever that is. So 500,000 divided by 642,000 equals log divided by 0.98 log equals, and I got that x equals 12.37. X equals 12.37. So, what is this telling us? So it says, what month and year? Well, if it's taking 12.37 years, right? 12.37 years. How many months is 0.37? 0.37 out of 12 months per year. 0.37 times 12 is 4.44 months. All right, so we know that it's 12 years, 4 months. How many days? What is 0.44 out of, I guess we'll say that the month is like 30 days a month, or, hold on, let me think. So, 0.44 months in days. Are they going to just multiply it by 30 and call months 30? So that'd be like 13.2 days. So what are we at? 12 years. That'd be 4 months. So July to August, August to September, September to October, October to November. So we're going to be in November. November what? Wouldn't it be like November 14th? 2000 and what? 23? They put November 2023. They didn't put the days. But you could have, right? All right, so then this is just making an exponential function to model the data around to 4 significant figures. Identify the parameters of the model, including growth and decay. All right, so Arizona population Y in thousands in years X since 1990. We're going to skip this for right now. you guys are going to do, in terms of your homework, page 531 and 532. You guys are going to do that should be fine. So, workbooks pages 531 and 532 in your additional practice pages. I hope you guys enjoyed this lesson. Please like and subscribe and have a fantastic day.